Hello and welcome to G Fun Facts Online. During the height of the recent global pandemic, we all became familiar with a new daily accessory, the disposable face mask. It was a simple, lightweight shield, a visible symbol of our collective fight against an invisible threat. But as we begin to move past the immediate crisis, a new, more persistent danger is coming into focus. A danger born from the very items that were meant to protect us. Today, we're uncovering the unseen fallout, how billions of discarded face masks are fueling a silent, pervasive pandemic of their own, a microplastic pandemic. Let's start with a number that's difficult to even comprehend. At the peak of the COVID-19 crisis, global estimates suggest we were using and throwing away 129 billion disposable face masks every single month. That's over 4 billion masks per day. With no effective, widespread recycling plans in place for the public, the vast majority of these have ended up in two places: landfills, or worse, our natural environment. They litter our streets, clog our rivers, and wash up on our beaches. This colossal mountain of plastic waste is now beginning to break down, unleashing a torrent of microscopic plastic particles and harmful chemicals into every corner of our ecosystems, posing a long-term threat we are only just beginning to understand. So what exactly is the problem? To grasp the environmental cost, you have to look at what these masks are made of. You might think they feel like paper or cloth, but that familiar blue surgical mask is actually a sophisticated, three-layer sandwich of non-woven polymer fabrics. The primary material is polypropylene, a type of plastic derived from petroleum. Polypropylene is fantastic for filtration, which is why it's used, but it has a major downside. It is not biodegradable. It won't decompose harmlessly back into the earth. Instead, over time, it undergoes a process of fragmentation. It simply breaks apart into smaller and smaller pieces, creating what scientists call microplastics, tiny plastic particles less than 5 millimeters in size and often much, much smaller. The scale of this fragmentation is genuinely staggering. One research study demonstrated that a single, fully weathered mask, after being exposed to the elements, can release several billion microplastic fibers into the water. The process is sped up by environmental factors. Sunlight causes what's known as photodegradation, making the plastic brittle. The constant weathering from wind and rain and the mechanical forces of waves and river currents all work together to shred these masks into a cloud of tiny particles. This means every single mask discarded improperly, whether it's in a landfill or floating in the ocean, is essentially a microplastic time bomb, slowly ticking away. But here's a more unsettling fact. The release of microplastics isn't just something that happens after a mask is thrown away. It's happening from the very beginning. Studies have found that even brand new, unused masks will start shedding microplastic particles and chemical additives when they're submerged in water. This suggests these pollutants are an inherent part of the mask from the moment it's manufactured. And the simple act of wearing a mask, with the constant friction, moisture from our breath, and stretching of the fabric, significantly increases the number of microplastics released. One fascinating study compared new and used masks. They found that a new disposable mask might release around 183 microplastic particles when agitated in water. But a used mask? That number jumped to over 246 particles. That's a 6 to 8-fold increase just from being worn for a few hours. The type of mask matters too. Those higher-grade filtering face pieces, like the N95, FFP2, and FFP3 masks, were found to release 3 to 4 times more microplastic particles than standard surgical masks. These particles are predominantly tiny fibers of polypropylene, often less than 100 micrometers in size, about the width of a human hair. But other plastics like polyethylene, polyester, nylon, and even PVC have also been detected, turning each mask into a complex source of multiple plastic pollutants. Now, it's crucial to understand that the problem isn't just the physical plastic particles. It's also about the chemical cocktail they carry. To make plastics like polypropylene more durable, flexible, colorful, and effective, manufacturers use a wide variety of chemical additives. These substances aren't permanently locked into the plastic's molecular structure. They can, and do, leach out into the environment as the plastic degrades. Recent research has been analyzing the water that masks have been submerged in, and the findings are deeply concerning. One of the most significant discoveries is the presence of bisphenol B, or BPB. You may have heard of its cousin, BPA. BPB is what's known as an endocrine-disrupting chemical. These are substances that can interfere with the hormone systems of both wildlife and humans. They can mimic or block natural hormones, potentially leading to a wide range of health problems, from reproductive issues to developmental disorders. It's been estimated that the sheer volume of single-use masks produced during the pandemic could have led to the release of hundreds of kilograms of BPB into the environment. And it doesn't stop there. Other studies have indicated that disposable masks can also leach toxic heavy metals like lead, cadmium, and antimony, as well as other volatile organic compounds, or VOCs, when exposed to different environmental conditions. These substances can accumulate in our soil and water, poisoning aquatic organisms and creating a pathway for toxins to enter the human food chain. The very tool designed to protect human health is now posing a new long-term risk to it through chemical contamination. Let's follow the journey of a single discarded mask. Imagine it's dropped on a city street. The next time it rains, it's washed into a storm drain. From there, it travels through the water system and eventually ends up in a river, which carries it out to the ocean. Once in our aquatic systems, these masks join the ever-growing problem of marine plastic pollution. There have been countless reports documenting a huge increase in the presence of disposable masks on beaches and in waterways worldwide since 2020. The impact on wildlife is direct and often brutal. Animals can mistake the masks for food, leading to internal injuries, blockages, and starvation. We've all seen the heartbreaking images of birds and marine life entangled in the ear loops, causing injury and death. But the more insidious threat comes from the microplastics they shed. These tiny particles are ingested by organisms at the very bottom of the food web, like zooplankton. When a small fish eats that zooplankton, the plastic accumulates in its body. When a larger fish eats that small fish, it ingests all the plastic its prey consumed. This process is called bioaccumulation. The plastic and the toxins attached to it become more and more concentrated as they move up the food chain, threatening the health of the entire marine ecosystem. And of course, this poses a direct risk to humans who consume seafood. But it's not just the oceans. Microplastics from masks can contaminate our drinking water sources. When that contaminated water is used for irrigation, the plastic particles can end up in our agricultural soil and even be taken up by the crops we eat. The full extent of microplastic infiltration into our food supply is still being investigated, but it is clear that the fallout from disposable masks is a major and very recent contributing factor. While we've focused a lot on what happens when masks are thrown away, there's a more immediate and personal risk we need to talk about: the inhalation of microplastics directly from the mask while you're wearing it. The same studies that showed masks shedding thousands of fibers into water raise a worrying question. If they're coming off in water, are they also coming off in the air we breathe through them? The irony is deeply concerning. A device whose primary function is to filter airborne particles may, in fact, be releasing its own particles directly into our airways. The health impacts of inhaling microplastics are still an area of very active research, but the potential for harm is significant. Because the fibers released by masks are so small, they can be inhaled deep into the lungs. Once there, they could cause inflammation, cellular damage, and contribute to other respiratory issues. The chemical additives we talked about earlier, the BPB, the heavy metals, could also pose a direct health risk upon inhalation. While the precise long-term consequences are not yet fully understood, the potential for chronic, low-level exposure to these airborne plastic particles is a serious concern that scientists are working hard to quantify. So, what do we do? This persistent pandemic of microplastic fallout demands a response on multiple fronts. It's a stark reminder of the hidden costs of our reliance on single-use plastics and highlights the urgent need for more sustainable thinking. One of the most immediate steps is simply better waste management. In hospitals and clinics, masks are typically treated as medical waste and incinerated, but for the general public, they've been treated as common trash. Public awareness campaigns that explain the environmental impact of mask litter and provide clear instructions on proper disposal. Cutting the ear loops and placing them securely in a closed bin are a crucial first step. In the longer term, the real solution lies in innovation. We need to develop more sustainable alternatives. This could mean creating truly biodegradable masks from plant-based materials that can decompose safely. Or it could involve designing high-quality reusable masks that offer excellent protection while generating minimal waste. Of course, for reusable masks to be a viable public health tool, we also need better public education on how to wash and handle them properly to maintain their effectiveness. And what about recycling? It's a challenge. The mixed material composition of masks, which includes different plastic layers, a metal nose piece, and elastic ear loops, makes them very difficult to process in standard recycling facilities. However, it's not impossible. Specialized recycling programs have emerged that can mechanically separate the different components. The valuable polypropylene can be melted down, processed into pellets and granules, and then used to manufacture entirely new products, things like plastic lumber for construction, outdoor furniture, shipping pallets, and toolboxes. Scaling up these initiatives and creating a circular economy for personal protective equipment could be a key part of mitigating the damage and turning a waste problem into a resource. Ultimately, the issue of microplastic pollution from disposable masks is a powerful, tangible case study of our planet's broader plastic problem. It shows how quickly a global crisis can create a massive, long-lasting environmental side effect. It highlights the urgent need for a fundamental shift in how we design, produce, use, and dispose of plastic products. As we continue to navigate the complex challenges of a post-pandemic world, we cannot afford to ignore the silent, persistent fallout that litters our planet, contaminates our water, and infiltrates our bodies. The choices we make today, as consumers, as innovators, and as policymakers, will determine the health of our planet and ourselves for generations to come. Thanks for tuning in to Fun Facts Online.